Hello everyone, welcome to my channel. Today we will continue the Unity Pro as part 3. In this section, we can see more on Modbus, how to use the read for and write for functions, and also for the third-party devices such as VFDs, MOVs, various instruments such as flow meters or pressure transmitter or anything. And also we can check for the soft starters, power meters, etc. Also, we can see the other functions along with this section. At the end of the sections, we will see more on how to make the memory mapping and also for how to make the I/O signals memory word for SCADA systems. In this example, if you see, there is one master PLC. This master PLC is connected with the SCADA system or programming tool or anything. And from the downside, you have the slave devices. If you see in this example, one of the slave device is connected directly and one of the slave device is connected through the gateway. So if you have multiple slave devices, you can connect up to 128 64 devices or 128 slave devices based on your requirements of that master PLC. Example, some of the master PLC have up to, you can connect up to 256 devices, up to 128 or up to 64. Okay. If you see on next example, here you can see in the PLCs you connected with Modbus TCP and also you connected with Modbus Plus and also you connected with Modbus ASCII or you connected with Modbus RTU. These all are slave devices. It is connected to the master PLC and it is communicating to the HMI. But if you see here, the main master in this system is SCADA system or HMI. But the main PLC is considered master for these slave devices. Even if it is instruments or any controllers, it is act as a slave devices in this layer. And if you see here, the data will be exchanged from Modbus TCP or Modbus RTU, either from RS-232 or 485 on the same time. So this is just for examples. Now we will go with some examples. Just open the application. Before opening the application, we will see some example for this master slave concepts. See, now this soft starter or VFD is considered as a slave device for any of the master RTUs. Here, if you go downside, this is anti-war trual. Okay, initially you need to understand what are the documents, example, or what are the details you need for configuring the slave devices. First point, you need to know the connections, hardware configurations. Example, if it's having the RJ45 connector, you need to know that where exactly you are going to connect your RS485 or RS232 connections. See here, we connected this RS485, it's connected with pin number 4 and 5. So this pin number 4 and 5 is RS485 plus and minus signal, D1 and D0. And the second point, you need to know that you already know now the physical connection. Now for the other connections, such as if you see the communication configuration, you need to know your slave ID. See here, this configured, this soft starter or VFD is configured up to 127 devices. Okay, so you have already the addresses. See, Modbus address 1 to 127. You have to configure your address. Okay, and you need to configure your baud rate. The default communication parameters are, here it is of Modbus address. You have to configure the Modbus address first. Then you have to configure your baud rate. It is 19,200 as default, and the Modbus format. You have to configure either 8 or 1. Okay, 8 means number of bits is 8. Usually in every slave devices or any devices you can, it is default as 8, and here you can configure either the parity is either odd or even or none, and also the stop bits you have to configure either 1 or 2. Okay, this is the choice you have, but you need to but default you have this one 8, even and 1. You can configure as per your configuration, but all the slave device you have to configure the same method. Okay, one you don't need to configure for 8 odd 1, and another one you don't need to configure 8 even 1, because if you configure different you cannot configure in your master PLC. Okay, so you need to be used as one constant, but only you need to change this address only. First device you can configure 1, second device address is 2, 3, 4, similar to that. And this is second step. Third step, you need to find your address. Okay, first of all you need to know that what are the parameters you are going to read from your slave device. Example, if you need to take the current or voltage or power or some feedback faults or trips, anything, first you need to find that address. Example, the source drive of the first input for ICS menu is this one. Even you can configure the menu directly from the device, like some of the inputs and outputs, submenus and submenus you can configure through these addresses. We can go further down. See here how the principal it looks like, master slave. See, this is one master and you have many slaves. You can use the slaves by serial. And first of all you need to understand the Modbus protocol concepts. Okay, you have one master and many slaves. Okay, but you need to know other functionality. Example, what is read holding register, what is write holding, and what is read or write multiple registers, and what functions you need to use. Example, 03 means holding register, 06 means the output word, and 16 means multiple registers, like this. So you need to understand that function before that, so it is very easy to configure your device. And if you see they are mentioning how the word, example, each words having low, high, how they configure 2 bytes. This is not very important to know everything, just at least if you are very familiar, it is very good to troubleshoot during that time, testing and commissioning time. So first of all, then you need to know which parameters you are going to read. We will see on second example, so you can see more on there. Also see here itself you can find switch. This is not ready to switch on, means there is no address, and switch on disabled, the address is 0050, and 31 is for switch ready to switch on, and fault you have 0038. So this is your register address, and they already mentioned that how you will configure in your Unity Pro. See here. Okay, in the serial configuration you have to make the configuration. Example, if it is usually you have to put master, because our master RTU you are configuring this one, no? So you need to give this one as master, and you have to give the settings of that same which one we see in upside, no? For transmission speed, parity, and everything. And also from this here you can see even they make with array for one data, because you have you need to read continuously. Example, 10 data or 15 data, 32 data, how much you need, you can add from array also. So from the array it will be read directly from M MW50 to MW58. It will read almost 8 registers, and from, if you see here, it will be read up to 4 registers. Okay, so you need to understand first, and also you see this is the main systematic diagram for Modbus master or slave concepts. If you see here, you can find how they you need to use the end resistors at the end, and each slave devices, it will be connected in series. This master and this slave devices, you can make 1 to up to number of devices, how much you have, you can connect. Okay, we will see on the next example. This is for the AUMA actuator. If you see the AUMA actuator, you have MOV. This one you have 1 to N, and it is, see, the 24 volt, it is loop. This is not 24 volt, sorry, it is to RS485 leak. This is connected through this one and make series for each one. And you can see here, see, there is different topologies they used. This is star topology, and this is loop topology, and this is the circuit inside you have in the AUMA actuator, and the resistors at the end, how you need to make coupling. And if you see here, this is for AUMA actuator for Modbus TCP IP. From here you can see the registers. See, 0, 5 is single coil, 15 is multiple coil, like that. Okay, so here see the diagnostic code. If you put the 08 means diagnostic, 08.00, see, this is the registers. So you can find the function code 08, and from this you can find up to 16 registers for each one having one fault. So you can find 08.0 means loop back, 01 means diagnostic registers, 02 bus message count. Similar to that, each functions have the detail, complete detail. If you go down, this is the registers also have some functions, and you can see further here, example here. See this one, if you 1000 is your address, okay, if 1000 you have 16, this is like registers, no? So you have 16 bits, each bit have one functions. 1000.:1 or .1 you can consider from here. Okay, thermal fault. Then 2 means it is false fault, phase fault. 3 means selector switch remote. 4 means selector switch local. Okay, these things you need to be verify, either the byte you need to understand which byte is first and which byte is last. See, if you see here, they mentioned already, byte 1 logical signal, byte 2 actuator signal. So just consider from here or from here, just you need to check during the time, because sometimes the registers will be flipped. Okay, so you need to find from there. So each registers have 16 bits. So you have first 1000, you have all these signals, local and actuator signal. 1001s you have these position transmitters, and 1002 you have device status. Similar to that, you have all the functions for one actuators. See, you can read even like 500,000 signals from one device. Okay, now we will move to our section. You will see how to create in Unity Pro. Just open the Unity Pro application. Okay, this one we already done before. We will continue with part 2. Okay, now already we created before this all the function, all the hardware configurations, derived function blocks, and we configured for elementary variables, communications, and also some logics before. So now in this section we will add for Modbus, read var, write var, and how to use these functions. So we will start from first one for hardware configuration. Just open the hardware configuration. From here you are using M340 2020 module. In this module CPU you have two things. One is Ethernet, one is serial. Okay, this one, if you double click this port, it will open your serial port. See here in the serial port you can connect either RS232 or RS485 based on your software configuration. Okay, so if I select RS232 means there is some disadvantage because you can connect one to one device only. You cannot connect multiple device on series. Okay, so you can go with RS485 and okay, if you select Modbus slave, this controller is used as a slave device. Here you can see the slave number. If you can increase what is the number you need, but the maximum you can use up to 247 slave devices in these controllers. If you use the same M340 PLC controller, you can use up to 247 controllers to connect with one master device. But in our concepts we are using this M340 as master. So you have to give RS230 or 485 links, and you have to give transmission speed, and you have to select RTU and stop bit 1 or 2 or parity, odd, even or none. Okay, based on our application which we selected in your device, you can use the same. Let's open a new section called Modbus. Okay, here you need to create now some of the devices. Example, I am planning to create now 3 devices. Modbus, initially we will create for 3 serial devices for Modbus. Okay, and we will make read and write for that functions, and we will call for 3 registers, different registers, and we can see how we can do this by step. If you have only one Modbus device, you can put directly read var, but here you have 3 devices, so you need to put some you need to call the devices by scanning, like device each 1 second I will call for one device. So what I can do now, I will put one counter. From this counter, if it is counter is equal to 1, it will call for first device. If the counter is equal to 2, it will call for second device. Same for third device. Okay, so see, if you need more detail regarding this read var, just click here and add read var, add this function. See, from this read var, then right click and go to type, and you can find the read var block here. See, from here you can find what is this address, what is this object, and it will mention what functions you can use for premium and for M340 and M580. Okay, and also what is num and what is NB, what is guest, everything you already have here, complete detail, even though I will explain during that creating time. And also you can see another one function called S7 here. See, now I am going to use per second, so I will use this function %S6. S6 is for each 1 second. Okay, this is applicable for all M580, all the devices. So minimize here, just delete. And first you can create one positive and put here percentage yes 6. This is for each 1 second. For positive you can find it will be count for your logic. Okay, so I will put operate. Okay. Okay. Even you can use here. See, for this one I will use temporary one name called counter. Add here counter. Maybe already I added before. Counter, it is integer. Okay, so I am going to use that counter here. Double click, give counter colon is equal to counter plus 1. So what it will do, each 1 second it will add, initially it is 0 plus 1 is 1. After next second it will become 2, because 1 plus 1 it's become 2. So it will be add up to how much you need. Example, I need for 3 counters. So what I will do now, I will compare one block, compare block. Here I will put here counter is greater than or equal to, I will use up to 3. Okay, so counter is greater than or equal to 3. I need to reset this counter. So you can put reset directly, or you can use this operate, like example, same operate again, and put counter. Counter is equal to 0. So here you need to put semicolon, colon, and here you have to put semicolon. See these two places. Otherwise it will give error, syntax error. So after you added this logic, this means your counter is ready to work now, because whenever it's 1 second it will add 1, or when it's become equal to 3 or greater than 3 it becomes 0. So 0, 1, 2, 3, 0, like it will be count up to 3 counts. Even it's count 4, but for 0 I will keep as rest. If it is like that, you can put equal to 1 also, counter 1, 1, 2, 3, 1, 2, 3, like this it will count. Okay, for me I will put for 0. Then now you added this logic. So now you need to add your read war block. Okay. Add FFP. Give read war. Okay, you already added the read war. See, in this, any of the block which you are using, just right click, and if you go properties, see here you have show enable or ENO. Okay, if you remove this ENO, it's not required any additional power. See, now you don't need to link with this input line to the output line, because it's already have see, you already removed from this. But when you added EN and ENO, means you have to link example, you have to, without this link the output will not execute, the run will not execute. So you have to link this one. Okay. This is normal procedure in any of the functions in the Unity Pro. Okay, now you added here directly, but for me what I will do, I will add one more function called, because for this address here you have to, when it should be enabled. Okay, this read var should be enabled. For this you can consider this one for first power meter. Okay, so what I will do now, I will make one command. Even you can add here commands. See, these commands you can I will keep here. I will drag this one big and I will give here first power meter 1. Meter 1 read var. Okay, here when it should be read, when the counter is equal to 1. So you have to add here compare. Okay, here you can copy if you need, or you can put directly. Q compare counter is equal to 1, because here you have to give semicolon. Here okay, no need to give here for this compare, just give counter is equal to 1, and it will be, once it's equal to 1, this will be execute. But here what is address? See this one, if you click, see here you can find that this is integer and the address buffer given by ADR or ADM, ADM. Okay, so you have to add here ADM. Okay. Right click and add the function called ADDM. If you need to know what is this ADDM, just right click, help on type, and you can find this function. Okay, this ADM function is used to convert the character string into the address. Okay, this one you are going to use your character strings to the address. Okay, now in our case, see here, if you see here, this is the one, see here, okay, rack module channel. Okay, and you otherwise you can give net link. This means IP address or host address, node address, or anything what you have. Okay, just you need to give the IP address, TCP IP or Modbus or Modbus net, whatever you have. See here, it's clearly it's mentioned for complete descriptions. Okay, this is netlink means what? Host address, IP address, and R means rack, module, channel, communication, nodes, systems, everything. So if you read this everything, you can find, see here, they will give directly like this. So in our case, okay, I am going to make the address for, see here I don't need Adam again. Okay, like enable or enable functions, so I will remove that functions. so I don't need to link here again and again. So just I will give Adam, and here you have to click and he has to give the address. I told you before, see this one you have to open, colon, open bracket, sorry, open colon, 0 dot 0 dot 0 dot 1, okay, and close this code. See, now this means, see, this is your, see, just open your application, this one, okay. What is this? 0 rack, sorry, 0 bus, 0 rack, 0 CPU, and this is your first channel serial 0001. So you have to give this one, you need to be first known which where you are exactly reading, because if you add this one Adam and if you link with this address ADR, then the function will execute with this serial port. So just add and link this one, say boolean link, just to link, right? Okay, because this should be in same line, so I just move. Boolean link. This is okay. I will move this function down. Give now link. You can do in two methods. One, you can give any one of the address. Example link. Add and type. Give link here. So it will be add and type link. Okay, wait, I will try in another way. Okay, we will see, maybe there is something error, we will troubleshoot later. But before that, for this object, see, it's already mentioned here, object to be read %mw, %m, or etc. So you have to know that which register you are reading in the power meter. Example, I am going to give you %mw. Okay, just give, okay. Object to read is %mw, and number of, what is the address, example person, you are reading from, yeah, %mw 36, and number of bits you are going to, number of registers you are going to read is 8. And now for this one you need to be know why this error. Just click here help on type, and you can find here object, see here you have to make open and close bracket. output we will see now. Okay, because you have to make your open and close, because for me I am using virtual machine, some of the functions it will not work in virtual machine. Okay, now you almost completed this side. You have to check the other side, this one. Okay, here you have to give that. See, now in your serial device you already given this is your address of the serial port, and from this serial port you are reading this memory word. Okay, MW example 36, and how many registers you are reading? Total number of register is 8. Okay, then you have to give here, okay, your where you need to write this detail. Okay, I will write in %MW example 134. Same you can give here, %MW 134, %MW 134. Okay. This integer, %MW 134. So here you can find what is the error. See, MW 134. Or you can put any of the name. Example, read one. Okay, it is asking. See, now you need to be making the array. Okay, it's mentioning array 1 to 2. Okay, this array we will see soon now. Just give okay now. Okay, I will tell you what is this array, why it is showing this, because you have %MW 36, you are reading up to 8 register, but you cannot store in only one output, like example 1 register. Therefore it is asking you to make in array format, so that only we have to create in the derived data types. See, here in the derived data types you have to add this read, or in the data variable here, see, you have to give this read. Okay, here read. See, here you have to be add more. I will show you. I will show you soon. DDT. This is read. Just save. Okay. Now just compile this function. Maybe you can see, because this one it is still blue color. No? This blue color means it's still not okay. Just compile. See, there is one error. Okay, this error, there is 3 error, this one. Okay, this is, see, you can find how you can find the error. See here, this one 7, this is the line number, 7 to column number 8, and column number 8, this is the read word, and it is telling that usage of dynamic array is disabled. And here second error, it is telling that object must be connected with the predecessor at least of the left power rail. So you have to connect this object in the left power rail. So this means you have to enable these functions to get, see this function, it's became now enabled, but still this function have error. See this this one, it's okay, and the third one, and this one no issue. See, this is for security, this one no issue. Just again compile. Okay, what is this one, E1208. Okay, this function usage of dynamic array is disabled. This one you need to be find in the tools, project settings, and go to general. From the general you have variables. See here, you can see the same word, dynamic array disabled. This one, check here, allow dynamic array, because here it's disabled here. So you have to give here to enable your dynamic array. So just click that one, apply, and okay. See, it's become black. Before this one become blue. So this means you are sure that there is no error. Okay, just now save, compile. And another thing I told you already, if you need to add the array number more, you have to click and go to these general attributes, and you can change here the array size. Okay, here click and it will go to the, see, it will go to the library. From here you have to change the array size. Okay, now just now give you, just make build. So it's built without any error. This means your logic is 100% okay now. Okay, without error. But you are not sure that the system Modbus slave is connected, because this is the one very troubleshooting point to know that where exactly the issues. You need to, based on your experience, you need to be verify lot of things. See, example, you connected here, you don't know, maybe this is not reading some values. So you have many troubleshoot diagnostic points. You need to check that one later. Initially you can create these things, like you already created for one power meter read for. Maybe you have in the same power meter, you have to read some other blocks, maybe other registers, because you read only 8 registers. Maybe this is for example for only for current. Okay, now you need to read for power. So you have to add your logic. Maybe you can give with the same counter is equal to 1, and you can see, I can copy paste this same logic. Or if you need to make with different type, you can add counter is equal to 2, and you can add for that. See now, wait. Okay. See now I will use the same counter is equal to 1 and the same device, and you are connected with 36. This one, maybe this is 128 register number, MB register number 128 up to percentage MW128. It will read up to, maybe this is for 4 registers. Okay, just give OK, and you have to change here read true. Okay, and here it will ask you if you array size default, it will come this size. If you need to change, you can change from there how we changed before for read 1. Okay, these functions, see, and other point I told you before, this is 0.0.0 and serial number, and this one, it's your slave ID. Okay, now your slave ID is 2. Okay, so you need to be add this one on the second one. Example, see, now you counted for first one, and now I will move to second power meter. Okay, this is for second power meter. What I will do, I will copy, same paste here. This is for power meter 2. And you can change here only this detail class. Okay, if you give this one, and you can give here counter is equal to true. So it will read you the second power meter. Okay, so you can make first one and copy paste for all the device and change only the counter name and the slave ID. So similarly you can do for the third one. Paste for third. This is for third power meter. Copy. This is for third power meter, and you can change this one, slave ID is 3, and here you can change for third read 3. Okay, so you already added for 3 and you added for with counter, each counter it will read for particular device. Okay, this is the basic concept of reading. And for troubleshooting point of view, just right click. Okay, if you need, just I will go to online, connect. I will show you because I am connected with simulator. Okay, rebuild all. Yes. Yes. Run the system. Okay, now see, now see the counter is 1. See, you need to if you need to verify, go to animation table, put counter. See, counter is equal to 0, 1, 2 and 0, 1, 2, because 3, whenever it is equal to 3, it's become, after that it becomes 0, but it will count the 3 also. So 0, 1, 2, 3. If you need, you can change this one to counter 0, counter 1, counter 2. Okay, so you already made. But you don't know this is really reading or not. How you know? See, just click here, go to this animation table. See, this is your guest, no? See here, 5. Okay, what is 5? If you don't have any idea for this one, just click here, go to the cell point type, display, and you can see here guest. See, you have three array of integer, each one having some functions. See, rank 1, rank 2, rank 3 and 4. 0 to 3 means it's 4 total. Okay, now for the first one it's showing that there is some error, no? If you need more detail regarding this, click this one. See here, you have here 2 things, 1, 2, 3, 4. No? Here, see, this is the one you need to find. Now, what is the report and what is the communication report? It's come 5. Incorrect parameter format. Management parameter 05. Where is the, okay, just click table guest 01. This is the second parameter. Even you can give, because see, you given for each one the same name, guest 1, guest 1, guest 1, no? So you can change this one to guest 2. Okay. Give guest 2, and even if you need to change data properties, change to 4. Double click, change to 4. Okay. After you change, build and run. See, if you save and build, it will be automatically, it will run. See, now the error become 3. What is that 3? Just click here again. 02 is 3, no? Okay, right click, go to endpoint type, go to the same place, check the communication structure. Even the communication report tree is incorrect address format. Okay, operation report. Okay, see, actually this is the thing, not that one, because there is 2 part, communication and operation report. So okay, so this one, if you see 3, no device or device without resource, means it's not connected with the device. Okay, so you can find if there is no error, and if you read this one, example, if you read from animation table, you can find the value. See, you can find the values from the meter, and also you can find from the LED itself. For example, see, whenever, just observe, you need to observe in the real physical device, go there, and you can observe here blinking continuously, this one. Okay, this one you have here display in your M340 CPU, and from the CPU, if it is continuously flashing, this means it's continuous, there is communication is there. If the flash is like it should be like milliseconds, you cannot count. Maybe if it's the flash is like some gaps for each one, means it is trying from your side, it is trying to transmit, but it's not receive any feedback from the slave devices. So based on your LED blink, you can find. I will attach that video at end of the session how it is blinking on the devices. I will send the original video of that one. At the time I will explain to you in the M580 PLCs. Okay. And even I will show you the live data from the field in the last session, like in the end of that session. So this is the thing how you are adding for the slave devices. Okay, now what I will do now, I will add for one TCP device. Thus in the TCP device everything is same. You have to add one additional things here. I will show you. Just copy this same and add downside. See here, instead of add, remove this one, change to ADDMEX. This one, AD. Okay, before that just click here, go to the help page. Okay, type here add max. ADDMX. Go here, type here better, ADDMX, see this one. Okay, this is the function you have to use for TCP IP, ADDMX. See this one, it is telling that the ADDMX function is used directly in the following function with local Modicon M340 PLC or remote M340 PLC module in a quantum systems. And ADDMX function can be used directly for the following communication functions in M580 systems. You can use these functions for this much application. See here. For our case, see, it is telling clearly that ADDMF function is used directly for the local CPU or remote in a quantum systems only. Okay, the system should be in this C here like this. Okay, this is if you are using with quantum series, you can connect to M580 and you can use this module, because this module you have to use some other modules like NOM. See here, it's mentioned already clearly. You have to use NOM modules, and you can make a serial or you can make a TCP connections for that. Okay, but for our case, if you are adding, see, if you are adding here NOC modules, then you can add that function of the ADDMX function. I will show you this one as example, not from this practice, but I will show you my another application. From there I will show you that how it is using. Okay, so and other thing, from there is many advantages to connect directly with. Nowadays you don't need to connect with RS485 serial links. Okay, you can connect directly through browser itself. There is some advantages I will show you now. Just I will save this one and I will open another logics. From there I will show you the DTM browser. Because still we have a lot of topics for, so I cannot able to cover completely. So I will open one of the logic here. I will show you how we added the ADVMX functions read var and write var. Write var is similarly same. Okay, instead of read var you are going to put you are adding write var. I will show here directly. See, here we added lot of read var and write var blocks. If you click any one of the, see here we make already derived function blocks for read var. Double click. And here we used as a derived function blocks, and that function we used outside. See here, this is all for TCP/IP. I told you there is only one difference. Here we used, there we used ADDM, here we use ADDMX. Okay, this is for TCP/IP because I keep here IP address as a string because I given everything in outside function, because we created this function is used in many places. We are collecting the data from more than 200 devices, so we keep everything outside and we make a derived function block for 2 pumps, 3, like type 1, type 2, type 3, like that. So this read var functions for enable, see this one we make enable, and this IP address and it's connected directly to address, and same you percentage MW up to MW50 it will read 8 registers, and we will check the status here, and this is the output here. Okay, part 1, part 2, like this. The same function if you go for the logics here, see here, see I use the same function 003. This is my IP address 10.1.41.150. so this is the port. Okay, you are connecting port na, before I explained you port 00000, and it is used for 3 because you are using for third port is for TCP/IP na, in your CPU. If you open your CPU, you can see here the third port. You have many ports. See, you have many ports you used in the third port for the connection for the TCP/IP. So we use that one 003. This everything it is available in the help. You can find from the help also. And for the write var, just click here. See these functions here, write IP. Click any one of the functions. This is similar to the read. There is nothing big difference. See, it is write var, and you can see the same enable address. This is the IP address, and this is the object percentage MW and number of percentage MW8 and 12 registers. And here one called EMIS, because here is the one you are writing the part 1, because this part 1 if you see, because this is the standard, and this part 1 if you see for write blocks, or if you just right click the help, and you can find that directly also. See here, this is the address you given directly. See, this is the write block, and this is the input value site ID we given, this is like optional, and this is the IP address, and this part 1 which I showed before, it's the register address only. Okay, and where you are writing, you see after you write, this will be go to these registers. CRA write bool activated. Instead of seeing here, you just see from here itself. in your block directly, so you can understand very well. See, right, and you did not given here enable, but see, this is the function. This all it is writing in this function. Okay, this percentage MW8 up to 12 registers, it will write to this. So if you have doubt, just click help and see the function here. You can find from here itself. See this one, EMIS word table containing the value which is to be written. Okay, this value it will be written in this integer and it will transfer to the particular devices. Okay. Now we will see, now we almost completed all the part, but because we don't have more time, so I will cover on the next session also. If you have any clarification, I will go with that in the next session. And also you need I will show you some other detail also. As per discussed before, I will show you how to make the memory, like input outputs, registers, everything. See here, example, you already created one application. Okay, just example, you created one application. You already made if you watch my video from part 1 all the parts, you can understand that I already make some registrations. See here, just click open and you can find all the IOs here which we used. This all like percentage I 0.1.0, all the registers we already mapped before. Okay, that mapped, see what we make here in one of the application, we mapped here. See percentage I 0. You can do in two way. One, you can directly give the address from how we used in the before part. See here. Where is this? Here. See in this part, if you see R elementary variable, I linked directly. See this one. Pump 1 remote, you just given the address directly. See, if you see here, this one, you click, select, okay, now okay, go to channel, it is already linked. Okay, this all we already linked here. Okay, if you go to this another application, we linked from year to year. It's not directly linked. See percentage I 0.1.0, we link to this address. So this is my what I make here. I make mapping of this address directly. See percentage I 0.1.0, I map it to this aerator building, aerator 1 remote. Okay, my address is percentage MW 0.0 and this is percentage MW 0.1, 0.2, 0.3 like this. So I already mapped the digital input signals completely. Okay. So we mapped this digital input either by, if you make by ladder logic, you can make like this. Otherwise, you can the easy way, you can map through function block diagram. It is very easy also. See mapping. Okay, just I put map. Okay, just click and use the function block. Use the function block, what bit 2, just if you don't know exactly the word, boolean 2, or you can browse here, integer to real like that. Na? So you can go to library, complete library, and you can find here boolean 2, boolean. 2 byte. See here, boolean 2 word. Just give here boolean 2 word. So all your 16 bits registers, it will be in one word. So this word you can give here any other example. First digital, complete digital 1. Okay, this is one word, and you can give the address of that. And here you can add the digital input signal, like example %I 0.1.0. This is not 0, this is I think 0. So this will be mapped with these registers. No? So you are mapping either single each one separately means you can use these registers like this, and this is like a bit by bit. Okay, and again in the SCADA you need to use the same bit by bit. But if you use this method, if you use one word for complete registers, okay, these registers, the DI1, so just go there, or I can give you DI2. See, I can give the address directly, %MW 14053 something. See, everything is in one registers. So it is easy to send only one word to the SCADA systems. Okay, this is one way. Otherwise, you have to give like bit by bit for DI. Okay, for DO, see here you have functions for output. So you are not directly linking with the DO. You are giving SCADA commands only. Okay, example, if you open any one of the application, see here you are not directly link the output of any of the functions. See, it is directly, because you are not giving directly command here, no? Because your logic should be satisfied, then only the output will on. So this is your SCADA manual example. So you are giving %MW 1006.1. Okay, this is your register address. It is coming from SCADA, and that registers will give you manual command, and it will check the logics, everything is executed. See, if you right click, you can refine the logic, and you can find what are this logic is executed, and after that the pump will start based on the auto sequence, everything. If it is satisfied, the output should be run. Okay, and you can see the daily, monthly run hours and everything. Okay, so this is your output. For analog inputs, if you see here, this is analog, and we mapped here for integer to real, and we get this. Okay, this is we make in structured text. And also if we go for our another application which we initially created, no? If you go here, open our tank level, see, you already mapped. You can take these registers, %MW 320. You can use this register as real because it's already scaled. So you can, if you need to use integer, you have to scale everything in the SCADA. But if you take this direct scale value, so real value, and it's scaled real, and so you can take this one in the SCADA without anything to be added in the SCADA systems. So if you add this one real, and if you put the maximum range, it will work automatically. Okay, and also you see here, you added the alarms, no? Low set points, and alarm. See, this low, this is alarm, and this is the set point. So you can add all the things the same. Example, memory words. If you add here, if you add a set point, low set points or some memory word registers, you can be directly taken to the SCADA. Otherwise, you need to make in the SCADA itself to make your limits and set points. There is two way to make, either from the PLC side or from the SCADA side. This is for analog input, similar for the analog output. So just we will go to now for mapping things. See, This is my IO list of these sites. See which one I showed here. This one. This is IO map. No? The same things you can find here. See aerator 1, remote, local, on, trip. This is the tag, this is the description, and this is the input number which we used in our PLC, and this is the normal signal list for DA. Okay. And if you go for DO, you have start command, stop command for all. I told you can use either start stop in same command, or you can use separate command also. And for analog, the aerator current and everything, this 4 to 20 milliamps signals. And here is the one, the main point which we configured here, because I told you aerator remote we use %MW 0.0 in PLC, but when it's come to SCADA you have to use 30001.0 because this is 0.0. So you have to use based on the requirement. Maybe some places I told you have to use 5-digit or 6-digit registers, but here we use 6-digit registers because based on the SCADA configuration. Okay, here 0.0 we used 40001. It's not compulsory that you use to 4001, you can use 30001 also, because 3 is read, 4 is read and write. Okay, 40001 means. So we use the remote address 001 because whenever %M0 means you have to put instead of 0 1. If you example if it is 1, %MW1 means you have to use 2. Okay, because in the PLC and SCADA, PLC what are the address you have in the PLC? Example memory word. Okay, MW30 means in the SCADA you have to put 40031 because this is based on the SCADA systems. Maybe some SCADA systems it's have the adjustment in the SCADA itself +1. Whenever you are add, it will be automatically in script +1. But usual practice, what are the address you have in your PLC, it should be added +1. Okay, this is for Boolean. And if you go for memory word for other details, just go below. See here, this is all for Boolean, and this is for your analog input. See current. Okay, this one here, current. If you use for current, this is your registers which you used in your PLC, %MW 300. This is your registers. Whenever you are using in your SCADA system, you have to use 400301. It's not 400. I told you can use 300301 also, and also similar for that same. And you have to use real because you already converted and you scaled in the SCADA systems. If you use the input itself, input registers, you can take that one also directly also, but you need to make scaling everything in the SCADA, as I told before. So this is the overview of how to make the you here for link the IOs and make in your SCADA system for that addresses, for the PLC and SCADA system addresses for the registers. So we almost completed the part for today's session, and we will see on the next session how to make DDT functions and how to make the array functions, because this one now currently we don't have time to make everything. So I will show you how to make the array, because this is very important, and also I think you already understand how I make the array before. I added here some arrays function. So you can add directly also for some arrays here, this one. or you can create first array, after that you can add in your function also. See, if you add even from the elementary variables also, just add any one of the name, read while, and here you can give array. See, array, and you can give you how much array you need. Example, I can give you up to 8 registers. See, it will be add array functions. Either you can directly add, see, this is array of integer, but this is array add up. So if you need to change, go here, array of integer, you just change here integer. I think you need to be first add here integer. Okay, I will show another one. Read 6. It says directly, see. So you can do in many method. Even if you click, you can change from here itself, you can add from here also. Just change maybe a 10, it will ask you here itself, no? So you can put here itself, but this will be take for your which one it's required, because if it is integer, it will come to you integer directly, or if it is real, it will be take directly real array. So the array, I will on next session I will explain more depth on array, because now we don't have time. So I will come with some additional sections also, not only array. We will cover some more on functions and more troubleshooting points, everything. In this video you can see this odd standby M580 PLC with OPC servers and also RS485 the readvar and writevar functions, and it is working perfectly. Thank you for watching this video. We will see on the next session. Thank you.